Imagine an aircraft so advanced, so alien in its appearance that it seems to defy the very laws of flight we have come to understand. This is the B-2 Spirit, a machine that represents a quantum leap in military aviation, a creation born from the intersection of breathtaking ambition and profound scientific ingenuity. It is not merely a bomber, it is a statement of technological dominance, a ghost in the global machine of defense. Its primary purpose, its entire reason for being, is to go where others cannot. To slip through the most sophisticated net of enemy defenses, as if it were not there at all, delivering its payload with unnerving precision before melting back into the darkness from which it came. This capability, known as stealth, is what makes the B-2 one of the most feared and respected aircraft ever to grace the skies. The B-2 Spirit is an object of superlatives. It is, by a significant margin, the most expensive aircraft ever built, with a price tag for each unit soaring to around $2 billion. This staggering cost is a direct reflection of the groundbreaking and often top-secret technologies packed within its sleek black frame. From its radar-absorbent skin to its revolutionary design and its complex computer systems, every single component is engineered for one ultimate goal: invisibility. It is a flying paradox, an enormous machine weighing over 70,000 kilograms, yet on an enemy radar screen, it can appear no larger than a bird. This ability to execute missions deep within hostile territory without being detected is what makes the B-2 a cornerstone of America's strategic power. This aircraft is more than just a weapon. It's a testament to human problem-solving on a grand scale. It answered a critical question faced by military planners. How do you maintain a credible deterrent when your opponent's defenses have become almost impenetrable? The B-2 was the audacious answer. It rewrote the rules of aerial warfare, proving that it was possible to hold any target on the planet at risk at any time, regardless of the air defenses protecting it. Its very existence forces potential adversaries to spend vast resources attempting to develop ways to counter it, shifting the strategic balance of power simply by being ready to fly. It is a symbol of a nation's resolve to push the boundaries of what is possible. Even today, decades after its first flight, the B-2 Spirit continues to captivate and intimidate. Its missions are often shrouded in secrecy, its full capabilities known only to a select few. When it appears in the skies, either on a training mission or during a public air show, it still looks like something from the distant future. This single aircraft embodies the pinnacle of aeronautical engineering, a fusion of physics, materials science, and computational power that came together to create something truly unique. It is a ghost, a spirit, and a powerful guardian, a silent warrior that patrols the upper atmosphere, ensuring that its presence is felt even when it cannot be seen. To understand why the B-2 Spirit was created, we must travel back in time to the tense, high-stakes environment of the Cold War. During the 1970s, the United States and the Soviet Union were locked in a perpetual standoff, a fragile peace maintained by the doctrine of mutually assured destruction. America's strategic bomber fleet, primarily composed of the venerable B-52 Stratofortress, was a key part of this nuclear triad. However, technology was advancing at a breakneck pace. The Soviets were developing increasingly sophisticated and interconnected air defense systems, featuring powerful radars and long-range surface-to-air missiles that could detect and destroy incoming bombers from hundreds of miles away. The shield was becoming stronger than the sword. A frightening reality began to set in for military strategists at the Pentagon. The aging B-52s, while still powerful, were large, loud, and had a massive radar signature. An Air Force general famously described the prospect of sending these bombers into Soviet airspace as being akin to throwing a rock at a hornet's nest. The likelihood of them reaching their targets was diminishing with each passing year. A new kind of weapon was needed, one that didn't rely on brute force or overwhelming numbers. The United States needed a bomber that could bypass the hornet's nest entirely, a platform that could render the enemy's multi-billion-dollar defense network obsolete simply by being completely invisible to it. This critical need gave rise to one of the most secretive and ambitious military projects in history, the Advanced Technology Bomber Program. Initiated in 1978 under a thick veil of secrecy, the program's objective was clear yet monumentally difficult: to design and build a manned strategic bomber that could penetrate the densest air defenses on Earth, completely undetected. The challenge was not just about making a plane slightly harder to see on radar, it was about creating a fundamental paradigm shift in aircraft design. The winning contractor, Northrop Corporation, would have to harness radical new ideas in aerodynamics, materials science, and computer control to achieve this seemingly impossible goal. The ATB program was therefore a direct response to the escalating technological arms race of the Cold War. It was a high-stakes gamble, betting that American innovation could outpace Soviet defensive capabilities. The project consumed a secret budget of billions of dollars long before the public even knew of its existence. The pressure to succeed was immense, as the strategic balance of global power hung in the balance. The result of this monumental effort would be an aircraft that looked and behaved like nothing that had come before it. The B-2 Spirit, a machine forged in the crucible of Cold War paranoia and technological ambition, designed to ensure that America always held the ultimate trump card. The B-2's radical shape, a feature central to its stealth capabilities, was not an entirely new idea. It was the resurrection of a brilliant yet previously unrealized vision from one of aviation's great pioneers, Jack Northrop. In the 1940s, Northrop was obsessed with the concept of the flying wing, an aircraft design that completely eliminates the traditional fuselage and tail. He believed that this pure wing shape was the most aerodynamically efficient form possible, reducing drag and maximizing lift, which would in turn allow for greater range and payload capacity. His passion led to the creation of several prototypes, most notably the jet-powered YB-49, which first took to the skies in 1947. The YB-49 was a machine far ahead of its time. With its massive 172-foot wingspan, it looked like a visitor from another world soaring over the California desert. It demonstrated the incredible potential of the flying wing design, proving Northrop's theories about its aerodynamic efficiency. However, the design had a critical flaw that 1940s technology could not overcome: inherent instability. Without a traditional tail and rudder to provide stability and control, the YB-49 was incredibly difficult and treacherous to fly. The pilots had to constantly fight the aircraft's natural tendency to yaw and pitch, making it an unsafe and unreliable platform. The era's mechanical and hydraulic flight control systems were simply not up to the task. Ultimately, the YB-49 program was cancelled in 1949, and in a move that broke Jack Northrop's heart, all existing prototypes were ordered to be destroyed. His dream of an efficient, long-range flying wing seemed to have died with them. For decades, the concept was relegated to the history books, a fascinating but failed experiment in aviation history. However, the fundamental physics that made the design so appealing hadn't changed. A flying wing with its smooth, continuous surfaces and lack of vertical fins had an exceptionally small radar cross-section. It was a shape that naturally deflected radar waves away from the source rather than reflecting them back. This was the key that would unlock the flying wing's potential a generation later. When the Advanced Technology Bomber program began in the late 1970s, Northrop's engineers revisited his visionary work. The crucial difference was the advent of the microprocessor and sophisticated digital flight control systems. With powerful computers, it was now possible to create a fly-by-wire system that could make thousands of micro-adjustments per second to the aircraft's control surfaces, keeping the inherently unstable flying wing perfectly stable in flight. The computer could do what no human pilot ever could. Jack Northrop's dream, once abandoned due to technological limitations, was finally resurrected, providing the perfect aerodynamic foundation for the world's first operational stealth bomber. The primary secret to the B-2's stealth is its extraordinary shape, an engineering masterpiece designed to trick radar. Radar works by sending out a pulse of radio energy and listening for the echo that bounces back from an object. The larger and more angular the object, the stronger the echo and the more visible it is on a radar screen. A conventional airplane with its flat tail fins, sharp wing edges and boxy fuselage is covered in surfaces that act like mirrors to radar waves, reflecting them directly back to the receiver. The B-2, however, was designed from the ground up to eliminate these reflective surfaces following a principle known as continuous curvature. The flying wing design is the ultimate expression of this principle. The aircraft's leading edges are carefully angled, not to cut through the air most efficiently, but to deflect incoming radar energy away from the source, like a tilted mirror reflecting light away from your eyes. There are no right angles anywhere on the aircraft's exterior. Every surface flows smoothly into the next, creating a single, blended body that offers no easy purchase for radar waves. The lack of a vertical tail fin, one of the biggest radar reflectors on a traditional plane, is perhaps the most significant design choice. This unique, bat-like shape ensures that almost all radar energy that strikes the B-2 is scattered harmlessly in other directions, leaving only a minuscule echo to return to the enemy's radar dish. This meticulous shaping extends to every last detail of the aircraft's construction. The B-2 is built from large, composite panels, which minimizes the number of seams or gaps between different parts of the skin. On a normal aircraft, these tiny gaps and panel lines can trap and reflect radar energy, creating bright spots on a radar display. On the B-2, these seams are filled and smoothed with extreme precision, creating an almost perfectly uniform surface. Even the access panels and landing gear doors are designed with sawtooth-patterned edges that help to scatter radar waves rather than reflect them. The entire philosophy is to make the aircraft as invisible as possible to the prying eyes of radio frequencies. The result of this fanatical attention to detail is a radar cross-section that is astonishingly small. While the exact figure is a closely guarded secret, it is widely reported to be the size of a large marble or a small bird. For comparison, a B-52 bomber has a radar cross-section equivalent to a large building. This means that from the perspective of an enemy radar operator, a 172-foot wide, 70-ton bomber flying towards them is indistinguishable from the random background noise and clutter that radar systems are designed to filter out. The B-2 doesn't just reduce its signature, it practically erases it, making it a true phantom of the skies. While the B-2's shape is its first line of defense against radar, it's complemented by a second, equally important layer of stealth technology: the materials it's made from. The bomber's black skin is not just paint, it's actually a complex and top-secret radar-absorbent material, or RAM. This special coating is, well, designed to do exactly what its name implies. When radar waves strike the B-2's surface, the RAM's unique chemical and physical properties absorb a significant portion of the energy, converting it into a tiny amount of heat. This process works much like how a dark-colored object absorbs sunlight. Instead of reflecting the radar energy back to the receiver, the B-2's skin effectively swallows it, further diminishing its already faint signature. The composition of this RAM is one of the most classified secrets in the US military. It's believed to be a multi-layered composite, likely involving carbon graphite structures and special ferromagnetic particles suspended in a polymer matrix. This material isn't only applied to the surface but is also integrated into the structure of the aircraft itself, particularly along the leading edges of the wings and around the engine intakes. The maintenance of this delicate and expensive skin is a monumental task. The B-2 requires climate-controlled hangars to protect the RAM from the elements, and the coating has to be, periodically inspected and reapplied to ensure its stealth properties aren't compromised by wear and tear. Beyond radar, modern defense systems also use infrared sensors to detect the heat signature of an aircraft's engines. The B-2's designers went to extraordinary lengths to make it as cold as possible to these heat-seeking eyes. The bomber's 4 powerful General Electric turbofan engines are buried deep within the thickest part of the wing structure. This placement hides the hot, spinning fan blades from being seen by radar from below. Furthermore, the air intakes are located on the top of the aircraft, shielding them from ground-based detection systems and helping to mask the engine noise from observers below. This design effectively puts a blanket over the noisiest and hottest parts of the plane. The most ingenious part of the B-2's heat suppression system is its exhaust. On a conventional jet, hot exhaust gases stream out of a circular nozzle, creating a brilliant heat signature that's easily targeted by infrared missiles. The B-2's exhaust, however, is channeled through long, trough-like vents on the upper surface of the aircraft. Before the hot air is released, it's mixed with cool bypass air, significantly lowering its temperature. These special vents then spread the cooled exhaust over a wide area, dissipating the heat signature so effectively that, from a distance, it becomes almost indistinguishable from the background thermal noise of the sky. This clever thermal management makes the B-2 a ghost to heat sensors as well as to radar. The B-2's flying wing design, so crucial for its stealth, creates a fundamental aerodynamic challenge. It's inherently unstable. Without the stabilizing influence of a tail, the aircraft constantly wants to pitch, roll, and yaw out of control. This is where the B-2's true genius lies, not just in its body but in its brain. The aircraft is managed by a highly advanced, quadruple-redundant digital fly-by-wire system. This network of powerful computers acts as the B-2's central nervous system. It takes the pilot's simple commands, like turn left or climb, and translates them into thousands of tiny, precise adjustments per second to the aircraft's control surfaces, which are cleverly integrated into the trailing edge of the wing. These computers are constantly at work, making minute corrections to keep the bomber flying smoothly, a task that would be impossible for a human pilot to manage alone. This computerized stability system is so sophisticated that it allows the massive B-2 to perform maneuvers with a grace and agility that would be unthinkable for an aircraft of its size. The fly-by-wire system is the invisible hand that tamed the wild instability of Jack Northrop's original flying wing concept, turning a dangerous design into a stable and reliable weapons platform. The pilot doesn't so much fly the B-2 as provide guidance to the powerful computers that are actually in command of the airframe. Inside the cockpit, the environment is just as advanced. The B-2 is operated by a crew of just two, a pilot, who handles the flight of the aircraft, and a mission commander, who is responsible for navigation, communications, and weapons deployment. They sit side by side in a glass cockpit dominated by multi-function digital displays. These screens can be configured to show a vast array of information, from flight data and engine performance to tactical maps and targeting information. This advanced avionics suite is designed to reduce the crew's workload during long, high-stress missions that can last for more than 30 hours, allowing them to manage the complex tasks of penetrating enemy airspace and delivering their payload. The B-2's electronic systems are designed with extreme redundancy and security in mind. It is equipped with a sophisticated navigation system that can operate even if the global positioning system is jammed or unavailable, using a celestial navigation unit to determine its position by tracking the stars, a modern update to an ancient technique. Its communications are heavily encrypted, and it possesses its own powerful electronic warfare suite designed to jam or deceive enemy radars that might get a fleeting glimpse of it. With over 130 onboard computers managing everything from flight control to environmental systems, the B-2 is less of a conventional aircraft and more of a highly intelligent, semi-autonomous flying supercomputer. The B-2 Spirit was designed not just to be stealthy, but to project power anywhere on the globe. Its incredible endurance is one of its most defining characteristics. With a full load of fuel, the B-2 has an unrefueled range of over 6,000 nautical miles, which is more than 11,000 kilometers. This allows it to fly from its home base in Missouri to targets virtually anywhere in the Eastern Hemisphere without needing to land. Furthermore, the B-2 is fully capable of aerial refueling, which extends its range to be effectively unlimited. This global reach means that no target is safe. A B-2 can take off from the continental United States and hold any location on Earth at risk within hours. This endurance is matched by an enormous payload capacity. The B-2 features two massive internal weapons bays, which can collectively carry up to 40,000 pounds or 20 tons of munitions. This allows for incredible mission flexibility. For a precision strike mission, a single B-2 can be loaded with up to 80 individual 500-pound GPS-guided bombs known as JDAMs, or Joint Direct Attack munitions. This enables one bomber to attack 80 different targets in a single pass, devastating an enemy's infrastructure with unparalleled efficiency. The B-2 can also carry massive, specialized weapons, such as the 30,000-pound GBU-57 Massive Ordnance Penetrator, a bunker-busting bomb designed to destroy deeply buried and hardened targets. Crucially, the B-2 is a key pillar of America's nuclear deterrent. It is a nuclear-capable bomber, designed to carry a variety of thermonuclear weapons, including the B-61 and B-83 gravity bombs. Its unique ability to penetrate heavily defended airspace makes it one of the most credible delivery systems in the nuclear triad, alongside submarine-launched ballistic missiles and land-based intercontinental ballistic missiles. The B-2 ensures that even a potential adversary with the most advanced air defenses cannot feel safe from a retaliatory strike, thus reinforcing the principle of deterrence that helps to prevent major conflicts. This nuclear role underscores its profound strategic importance far beyond conventional warfare. The aircraft is also designed to operate in any environment, day or night, and in all weather conditions. It is equipped with a sophisticated Ku-band synthetic aperture radar, which allows the pilots to create detailed maps of the terrain below, even through thick clouds or darkness. This system enables the B-2 to fly at low altitudes using an automatic terrain following and terrain avoidance mode, hugging the ground to stay below enemy radar coverage. This combination of all-weather capability, massive payload and intercontinental range makes the B-2 Spirit one of the most formidable and flexible power projection tools ever created. The B-2's unprecedented capabilities came at an equally unprecedented cost. When all research, development, and production costs are factored in, each B-2 Spirit aircraft is estimated to have a price tag of approximately $2.1 billion. This makes it, by a wide margin, the most expensive aircraft ever to fly. This astronomical figure is a direct result of the revolutionary technologies developed specifically for the program: the cutting-edge, secret radar-absorbent materials, the precision manufacturing required for the continuous curvature design, and the development of the highly complex fly-by-wire computer systems all contributed to the massive expense. It was, quite literally, the price of inventing the future of aviation. The original plan during the Cold War was to build a fleet of 132 of these stealth bombers. However, with the dissolution of the Soviet Union in 1991, the primary threat that the B-2 was designed to counter had vanished. In a new geopolitical landscape, the justification for such a large and expensive fleet of strategic bombers became a subject of intense political and budgetary debate. As a result, the production run was drastically cut short. In the end, only 21 B-2s were ever built, including the initial test prototype. This small fleet size dramatically increased the per-unit cost, as the enormous development expenses had to be spread across far fewer aircraft. The high cost of the B-2 extends far beyond its initial purchase price. The bomber is an incredibly complex and delicate machine that requires an extraordinary amount of maintenance to keep it mission-ready. The radar-absorbent skin is particularly sensitive and requires constant care. Each B-2 must be housed in a specialized, climate-controlled hangar to protect its stealth coatings from humidity and temperature fluctuations. After every flight, the skin must be meticulously inspected for any nicks or scratches, as even the smallest imperfection can compromise its radar-absorbing properties. The regular reapplication and curing of these special materials is a time-consuming and costly process, contributing to a very high cost per flight hour. This combination of a staggeringly high acquisition cost, a very small fleet size, and intensive, expensive maintenance requirements makes the B-2 a precious and carefully managed national asset. The loss of even one aircraft would represent a significant blow, not just financially but strategically. While its capabilities are unmatched, its cost and complexity mean that it is reserved for only the most critical missions, where its unique ability to operate undetected is absolutely essential. The B-2 Spirit stands as a powerful lesson in the economics of defense. Achieving technological supremacy on this scale demands a truly monumental investment. For over 3 decades, the B-2 Spirit has reigned as the undisputed king of stealth aviation, a symbol of American air power. However, technology never stands still. Potential adversaries have been studying the B-2 for years, working to develop more advanced radars and sensor networks capable of detecting even low-observable aircraft. To maintain its strategic edge for the coming decades, the United States Air Force initiated the development of a successor, a next-generation stealth bomber known as the B-21 Raider. This new aircraft is not just an upgrade, it represents the next evolutionary step in the philosophy that began with the B-2. The B-21 Raider, which shares the same iconic flying wing shape as its predecessor, is being designed to be the centerpiece of the future bomber fleet. One of the primary goals of the B-21 program is to learn from the lessons of the B-2, particularly concerning cost and maintainability. The Raider is intended to be significantly more affordable to produce and operate, allowing the Air Force to procure a much larger fleet. The current plan calls for at least 100 aircraft. This larger fleet size will make the force more resilient and flexible. By using modern manufacturing techniques and more durable stealth materials, the B-21 is being engineered to be less reliant on specialized hangars and easier to maintain in the field. The B-21 is being designed as the world's first 6th-generation aircraft. This means it will be much more than just a bomber. It is being built with an open architecture for its computer systems, allowing for rapid and easy upgrades to its software and hardware over its lifespan. This will enable it to adapt to new threats without requiring a complete redesign. The B-21 is envisioned as a multi-role platform, capable of not only delivering devastating payloads, but also acting as an intelligence, surveillance and reconnaissance hub, and a command and control node within a larger network of interconnected military assets, including drones, fighters, and satellites. The B-2 Spirit was a revolutionary machine that fundamentally changed the calculus of air warfare. It proved that invisibility was achievable, forcing a global shift in defense strategy. It was an icon of Cold War engineering, a testament to what could be accomplished when a nation dedicates its resources to pushing the absolute limits of science and technology. As the B-2 fleet gracefully ages and prepares to pass the torch, the B-21 Raider stands ready to carry that legacy forward. The insane engineering of the B-2 Spirit not only gave America a decisive military advantage for a generation, but also paved the way for a future where the sky is ruled not by what you can see, but by what you cannot.